Hello friends, in this video I'm going to teach you about what is Fourier transform. It is one of the important concepts in digital signal processing and signals and systems. Most of the students having the doubt in this concept and most of the students don't know what is exactly Fourier transform and why we are doing Fourier transform. Let's see, in this video I'm going to teach you what is exactly Fourier transform and how we are going to do Fourier transform and what are the advantages of Fourier transform. Now let's see first. We know all these signals are appeared in time domain only. In general, all these signals are having time domain only. Time domain is nothing but here the amplitude of the signal is varying with respect to time. Okay, in general, all signals are available in time domain only. But in our electronics, we need frequency as a reference. We know in all electronic devices we say the frequency as a reference. Like whenever a friend asks you what is your frequency, I mean what is your mobile frequency, then you can say my mobile frequency is 1.5 gigahertz or 1 gigahertz, and someone says my laptop frequency is 2.5 gigahertz, like that. That means your laptop works on 1.5 gigahertz frequency. That means that much fast it will work. So in all electronic devices we use frequency as a reference, not a time. In order to take frequency as a reference, we need to convert this time domain signal into frequency referenced signal. That means here signal is not converted into frequency domain. It just referenced to the frequency. That means instead of time, here we are going to take frequency as a reference. Now let's see, the Fourier transform is just convert the time domain signal into frequency domain signal. Here frequency domain is nothing but the signal is not going to convert into frequency. It is just reference to frequency. That means at which frequency the amplitude is. Here time domain signal into frequency domain signal. Now see here, he was the scientist who invented the Fourier transform. His name is Jean Baptiste Joseph Fourier. Let's see here, these are the time domain signals, that is S of t, sinc function, Gaussian wave, and double exponential. These are the some of the examples of signals, that is time domain signals. If we convert this time domain signal into Fourier transform, this looks like this. Okay, I will explain you how we can convert the time domain signal into frequency domain signal. Here one more thing we have to observe, that is in time domain signal, here the reference line, that is x-axis is time, that is t, and whereas in the Fourier transformed signal, after transforming our time domain signal into frequency domain, the x-axis is omega or f. Omega is nothing but frequency in terms of radians, f is nothing but frequency in terms of hertz. Okay, let's see here few more points. In simple terms, the Fourier transform takes a time domain signal and converts into its frequency domain representation. Already told you, Fourier transform is simply takes the time domain signal and converts its time into its corresponding frequency. Okay, and revealing the frequency components present in the original signal. It is widely used in various fields including signal processing, telecommunication, audio and image analysis, and many other areas. I already told you, it is just revealing what is the frequency component present at particular amplitude. Okay, we know in time domain signal we can say what is the amplitude of a signal at particular time. We can directly say by seeing, but we can't say what is the particular amplitude at particular frequency. In order to achieve that, in order to derive that one, we are using Fourier transform. And here let's see what is the mathematical formula to use to find the Fourier transform. That is the formula for continuous Fourier transform of function f of t is given by, okay, that is f of omega is equal to integral f of t into e power minus j omega t dt. It is the formula to find the Fourier transform of continuous time domain signal, that is f of t. Here let's see, f of t is the continuous time domain signal. In order to find f of omega is nothing but frequency domain signal, we need to integrate this continuous time domain signal and multiply with the exponential signal. Okay, and here observe where f of omega represent the frequency domain representation of a signal. F of omega is frequency domain representation. That is, after converting our time domain f of t signal, it will become f of omega. And f of t is a time domain signal we want to analyze. That is, here we can observe one more thing here. This f of t is small f of t and this f of omega is capital F of omega. You should remember this point, that is, whenever our signal is in time domain, we should represent that signal in terms of small letters only, like small x of t, small y of t, like that. And whenever we converted our time domain signal into frequency domain signal, we should represent that thing in capital letters, that is capital x of omega and capital y of omega, like that. Okay, when the signal is in frequency domain, we should represent that signal in capital letters. When the signal is in time domain, we should represent that signal in small letters. These are the basic things. And here omega is nothing but it's an angular frequency, or we can say it's a frequency in terms of radians per second. Okay, and let's see few more advantages of Fourier transform. What are the advantages of Fourier transform? Why we are not using the time domain signal as a reference signal? Why we are converting the time domain signal into frequency domain signal for taking a particular reference? What are the advantages? Let's see here one by one. Frequency analysis. We know in every electronic system, its a reference is frequency. That is, it is analyzed by using the frequency. By using frequency analysis, we should have the signal in terms of frequency only. So, in order to convert the time domain into frequency domain, what method we are using? Fourier transform. That is the advantage of Fourier transform in frequency analysis. And signal filtering. We know in all filters, almost 99.99% filters using frequency as a reference, and it filter out. It filter particular amount of frequency and it only allow the only particular amount of frequency. That means here filters also using the frequency as a reference. In order to take frequency as a reference, we need to first convert our time domain signal into frequency domain signal. So in filters also this Fourier transform is used. And third one is convolution and deconvolution. In while doing the convolution of two signals and while deconvolute the two signals, we are going to use this Fourier transform also. Next, time frequency trade-off. In order to do trade-off between time and frequency domains, we are going to use this Fourier transform. And the fifth one is computation efficiency. When we consider the time domain signal and as well as frequency domain signal is having the more computational efficiency or and more speed. That means when we convert the signal into frequency domain signal, then we can do more operations within less time. That is, computational speed and computational efficiency is also good in frequency domain. And harmonic analysis. In order to do harmonic analysis also, we are using Fourier transform. And that's all about Fourier transform. I hope you understood this topic. Thank you for watching this video. Please subscribe our channel and thank you.